All right, get ready for a pretty cool cosmic detective story. We're going to dive into how astronomers are using artificial intelligence to sift through this absolute sea of stars to find a single ancient family. And our main subject today? A beautiful star cluster called Messier 48.
You know, it really all comes down to this one huge question. When you look up at the night sky, you are looking at billions and billions of stars. So how in the world do you find one single family in a crowd that big?
To even start to answer that, let's meet the family we're talking about. We're heading out to an open star cluster known to us as Messier 48. Okay, so let's get the basics on M48. It's hanging out about 2,500 light-years away, kind of on the border between the constellations Monoceros and Hydra. It's what you might call a middle-aged cluster, clocking in at around 450 million years old. And it's got this great backstory. For a long, long time, it was a lost object. The famous astronomer Charles Messier actually wrote down the wrong coordinates back in 1781. He was off by 5 degrees, which is a lot, and it took ages for anyone to find it again.
But, that little historical mix-up, it's really nothing compared to the challenge astronomers deal with every single day. They call it the cosmic membership problem. So here's the deal. When we look up at the sky, everything looks flat. We completely lose all sense of depth. It's kind of like looking at a picture of a packed stadium and trying to pick out just one specific tour group. Everybody's just jumbled together.
The issue is caused by what you could call cosmic photobombers. Seriously, you've got foreground stars that are actually between us and the cluster, and then you have background stars that are way, way beyond it. But from here on Earth, they all just photobomb the picture, making it almost impossible to tell which stars are the real family members and which are just strangers passing through the shot.
So, how do we solve this thing? Well, astronomers have been working on tools for more than 100 years. But right now, we're in the middle of a massive data revolution, and it's all thanks to AI.
For most of the last century, the main tool was something called proper motion, which is just the slow, tiny drift of stars across our line of sight. The idea is true cluster members should all be moving together, kind of like a flock of birds. Today, we mix that with parallax, which helps us measure distance, and radial velocity, which tells us if a star is moving towards us or away. But the real game changer was the Gaia space mission. Since 2016, it has given us unbelievably precise data on almost 2 billion stars. That's not a stream of data, it's a tsunami.
And this gets us to the new reality for astronomy. A research paper from 2022 put it perfectly. With the insane amount of data coming from missions like Gaia, using machine learning is, and I quote, mandatory. There's just no way a human being could possibly sort through it all.
Okay, so how does an AI actually do this? How does it become a cosmic detective? Well, the secret is in a technique called unsupervised machine learning.
What's so cool about this type of AI is that you don't train it by showing it pictures of star clusters. Nope, you just dump this giant, messy pile of data on it and say, go find the patterns. It just goes to work, like a digital detective, searching for hidden groups and structures all by itself. It's the perfect tool for finding that one tour group in that ridiculously crowded stadium. The whole thing is this clever, two-step investigation. First up, an algorithm called DBSCN does a big, broad sweep. You can think of it like a bouncer at a club. It's only looking for dense groups of stars that are all moving in the same direction and are at roughly the same distance. That gives us a list of likely candidates. Then, a second algorithm called GMM comes in and takes a closer look. It's like a detective that interrogates each one of those candidates and assigns it a really precise probability of being a true member of the club.
So this is what the AI is up against. It's a plot showing the motion of a ton of stars, and every dot is a star. The real cluster members are in there, I promise, all moving together, but they are completely lost in this sea of random noise from thousands of other stars. Trying to find them by eye is basically impossible.
But here's the magic. To the machine learning algorithms, this isn't just noise, it's a puzzle. And by looking at motion and distance across multiple dimensions, the AI just slices right through all that static. It finds and isolates that one small group of dots that are all traveling together through space, finally revealing the cluster's true family.
So, after running this powerful digital investigation on all that Messier 48 data, what was the final verdict? What did it find? The answer is 452. After sifting through thousands of stars in that patch of sky, the algorithms identified 452 of them as being high-probability, true blue members of the Messier 48 family. And we are very confident the AI got it right because of this.
when you plot those 452 stars on something called a color magnitude diagram. It basically just compares a star's brightness to its temperature. They don't make a random mess. Instead, they form this perfect, clean line. For astronomers, this is the smoking gun. It's the proof that says, yes, these stars all have the same age, the same origin story, they were absolutely born together.
And this is exactly why it matters so much. Having a clean, confirmed list of members like this turns the cluster into a perfect cosmic laboratory. Now we can figure out its age with incredible precision. We can see firsthand how stars of different sizes live and die, because we know they all started out at the same time. And we can analyze the light to understand the exact chemical soup of the gas cloud they were born from, hundreds of millions of years ago.
So we've gone from a lost object with a fuzzy identity to a precisely defined family of 452 stars. And it's all because of this flood of new data and the AI smart enough to make sense of it. It really makes you wonder, right? If AI can already do this, if it can untangle the history of a whole family of stars, what other cosmic secrets is it just about to unlock?